Assalamu alaikum wa rahmatullah, dear students. Today, inshallah, we're going to talk about chapter 8 regarding IP addressing. And in this chapter, we're going to talk about three major sections. The first one is IP address version 4 networks. In that section, we're going to talk about the main IP version 4 address structure and how to calculate the subnet mask which is what we use for network planning. And also how to calculate unicast or how to recognize unicast, broadcast, and multicast addresses, and then how to recognize the different or how to categorize the different types of IP address version 4. Then we're going to talk about section 2, which summarizes IP address version 6. In that section, we're going to talk about the issues in IP address version 4 that led to the development of IP address version 6. Then we're going to talk about the IP address version 6 structure, the different types of IP address version 6. And then we're going to talk about the unicast, broadcast, and multicast. Actually, there's no broadcast in IP address version 6. Unicast and multicast addresses. In section 3 here, we're going to talk about the connectivity verification using ICMP protocol, where we will learn how to ping a remote host or a remote network in order to verify the connectivity to that host or that network. All right, so to start, we need some binary numbers background. So as we all know, computers actually represent any kind of data, including characters, video, audio, and everything, using binary representation. So for example, letters are represented using the ASCII translation. So letter A, for example, is translated into this binary combination and so on. So similarly, the IP address version 4 structure is composed of 32-bit binary representation, as we have learned before. In order for us to use the IP address version 4, we use the dot decimal notation. The dot decimal notation takes the 32-bit binary representation of the IP address and divide that into 4 what we call octets. And then each octet is represented using the decimal conversion of the binary representation. So the octets are, each one is like 8 bits, and then each 8-bit is converted into decimal. So that's the 32-bit representation of the IP address. So in order for us to convert from, in order for us to deal with the IP address version 4, we need to be familiar with how to convert octets from binary to decimal, from decimal to binary, and so on. And that's a very important task that we need to learn together. For example, so in that example here, we have represented 192 as 1 in the most significant bit, and then 1 in the bit next to it, and then the rest will be 0. So if we represent this 1, which corresponds to 2 to the power 7, or 128, and this one corresponds to 2 to the power 6, which is actually 64. So if we add 192 plus 64, that's 128 plus 64, that's 192. So that's how we convert from decimal to binary. And we will talk about many examples later on about how to convert from decimal to binary and from binary to decimal. So the way that we convert that is by recognizing. So for each octet here, we need to recognize that the most significant bit corresponds to 2 to the power 7. The one next to it corresponds to 2 to the power 6, and this corresponds to 2 to the power 5, and so on, until we reach this one, which is 2 to the power 0. So we start from 0 all the way to 7. So in order to represent any decimal number, we need to put any one combination in one of these bits to represent the decimal number, as we will see in this animation here. So if we run this animation, we can represent these ones and zeros in the different exponents. So for example, 192 is represented using 1 in the most significant bit and 1 in the bit next to it. That's 128 plus 64, that's 192. In the next octet, we can represent 168, which is 128 plus 32 plus 8, that's 168. And here we can represent digit 10 as 8 plus 2, and then we can represent the next digit as also 8 plus 2. That makes it that makes the whole address 198.168.10.10. So in this exercise, we can learn how to convert from binary to decimal. In this bit representation, for example, we have 0 and then 1, 1, and then 1 and 1 at the least significant bit. So this one here corresponds to 64, so we'll add 64 plus 32. That's 96 plus 1 here is 3, or 2 plus 1. So 96 plus 3, that's 99. So if we put 99 here, and we check, alhamdulillah, so it's correct. So we can try different numbers here and learn or get familiar with how to convert from binary to decimal. So the other way around is that we need to convert from decimal to binary. In many cases, when we get an IP address and we need to know if that IP address actually belongs to a particular network or subnetwork, in many cases we need to convert from decimal to binary. And the way to do that is to compare the octet. So if we have a decimal number, we first need to see whether it's greater than the most significant bit, which corresponds to 128. So first, if it's greater than 128, then we put 1 here. And then we subtract 128 from the original number. So for example, if we have a number which is 168, so 168 is greater than 128, in which case we'll put a 1 here, and then we subtract 168 from 128. That's 40. And then we'll take the number 40, and then we'll say whether it's greater than 64 or not. The answer is no in that case. Then we put 0 here. That's what happens in the next step. So if the answer is no, then we put 0, and then we switch to the next bit. If 40 is greater than 32, which in that case is 2, then we put 1 here, and then we subtract 40 from 32. That's 8. So that's what happens in step 3. And we keep doing that until we represent the whole number, which is in that case will be 1, 0, 1, 0, 1, and then 3 zeros, because 8 corresponds to 1 here, as we can see. So that's how we represent or convert from decimal to binary. And this step is also very important in many cases, and we'll see many scenarios where we need to convert from decimal to binary or binary to decimal. So the way we deal with IP address and to do some IP address planning or assign IP addresses to different subnets, we need to convert each part of the IP address, or each byte, or each octet, as we have discussed, into binary representation. So for example, 192 is actually 1, 1, and all zeros. 1 at 128 and 1 at 64. That's 128 plus 64. That's 192. and then we need to convert 168, and similarly, and so on. So that's what happens in each step here. So so we represent 192, and then we represent 168, and we represent 10, which is of course easy, and then we represent 10. So we convert the IP address into the binary representation. In many cases, we don't need to convert all the octets, and we will learn some tricks how to convert only 1 or 2 octets from the IP address into the binary representation in order to deal with that IP address, as we will see later. So in that exercise here, we need to learn how to convert from decimal to binary. So 38, as we said before, 38. So we need to see if it's greater than 128. Then we put 1 in the most significant bit. In that case, it's not greater than 128. So here is 0. And if it's greater than 64, then the answer is also no. So we put here 0. If it's greater than 32, in that case, that's true. And in that case, we need to put 1 here. So we subtract 32 from 38. We end up with 6. And 6 is not greater than 16. So we put here 0. And 6 is not greater than 8. We put here 0. And 6 is greater than 4. So we put here 1. And subtract 4 from 6, which we end up with 2, and 2 is actually 1 here, and then 0. Let's hope that our calculation is correct. So it's correct, alhamdulillah. So that's how we convert from decimal to binary. So similarly here, 199, that's 128 plus 64, that's 192. And the rest will be 7. So it's 7 is actually 111 here. So the rest will be 0, 0, 0, 1, 1, 1. So it's correct, alhamdulillah. So that's how we convert from decimal to binary. I encourage students to also go through that game. Which is here. So if we start the game here, so 34, for example, is 32 plus 2, and here. So okay, so that's correct. 1 here, this is actually 32. So we put 3, 2, and then we put like this. So that's 8. That's correct. 2, for example, is 0 like this, so that disappears, and 16 is in fact 0, 0, 1 here, so that disappears, and this is of course 2. Okay, so that's how we play that game.